Automobile safety is the study and practice of design cars, construction, equipment and regulation to minimize the occurrence and consequences of traffic collisions. Road traffic safety more broadly includes roadway design. One of the first formal academic studies into improving vehicle safety was by Cornell Aeronautical Laboratory of Buffalo, New York. The main conclusion of their extensive report is the crucial importance of seat belts and padded dashboards. However, the primary vector of traffic-related deaths and injuries is the disproportionate mass and velocity of an automobile compared to that of the predominant victim, the pedestrian. In the United States, a pedestrian is injured by an automobile every 8 minutes, and are 1.5 times more likely than a vehicle's occupants to be killed in an automobile crash per outing. Improvements in roadway and automobile designs have steadily reduced injury and death rates in all first-world countries. Nevertheless, auto collisions are the leading cause of injury-related deaths, an estimated total of 1.2 million in 2004, or 25% of the total from all causes. Of those killed by autos, nearly two-thirds are pedestrians. Risk compensation theory has been used in arguments against safety devices, regulations and modifications of vehicles despite the efficacy of saving lives. Occupational driving. Work-related roadway crashes are the leading cause of death from traumatic injuries in the U.S. workplace. They accounted for nearly 12,000 deaths between 1992 and 2000. Deaths and injuries from these roadway crashes result in increased costs to employers and lost productivity in addition to their toll in human suffering. Truck drivers tend to endure higher fatality rates than workers in other occupations, but concerns about motor vehicle safety in the workplace are not limited to those surrounding the operation of large trucks. Workers outside the motor carrier industry routinely operate company-owned vehicles for deliveries, sales and repair calls, client visits etc. In these instances, the employer providing the vehicle generally plays a major role in setting safety, maintenance, and training policy. As in non-occupational driving, young drivers are especially at risk. In the workplace, 45% of all fatal injuries to workers under age 18 between 1992 and 2000 in the United States resulted from transportation incidents. Active and passive safety. The terms active and passive are simple but important terms in the world of automotive safety. Active safety is used to refer to technology assisting in the prevention of a crash, and passive safety to components of the vehicle that help to protect occupants during a crash. Crash avoidance equals. Crash avoidance systems and devices help the driver and, increasingly, help the vehicle itself to avoid a collision. This category includes the vehicle's headlamps, reflectors, and other lights and signals, the vehicle's mirrors, the vehicle's brakes, steering, and suspension systems. Driver assistance. A subset of crash avoidance is driver assistance systems, which help the driver to detect obstacles and to control the vehicle. Driver assistance systems include DADS, Driver Alertness Detection System to prevent crashes caused by fatigue, automatic braking systems to prevent or reduce the severity of collision. Infrared night vision systems to increase seeing distance beyond headlamp range. Adaptive headlamps control the direction and range of the headlight beams to light the driver's way through curves and maximize seeing distance without partially blinding other drivers. Reverse backup sensors, which alert drivers to difficult-to-see objects in their path when reversing. Backup camera. Adaptive cruise control, which maintains a safe distance from the vehicle in front. Lane departure warning systems to alert the driver of an unintended departure from the intended lane of travel. Tire pressure monitoring systems or deflation detection systems. Traction control systems which restore traction if driven wheels begin to spin. Electronic stability control, which intervenes to avert an impending loss of control. Anti-lock braking systems. Electronic brake force distribution systems. Emergency brake assist systems. Cornering brake control systems. Pre-crash system. Automated parking system. Obstacle detection sensor systems notify a driver how close their vehicle is to an object, usually providing a distance measurement, to the inch, as to how close they are. Crashworthiness equals. Crashworthy systems and devices prevent or reduce the severity of injuries when a crash is imminent or actually happening. Much research is carried out using anthropomorphic crash test dummies. Seatbelts limit the forward motion of an occupant, stretch to absorb energy, to lengthen the time of the occupant's negative acceleration in a crash, reducing the loading on the occupant's body. Prevent occupants being ejected from the vehicle and ensure that they are in the correct position for the operation of the airbags. Airbags inflate to cushion the impact of a vehicle occupant with various parts of the vehicle's interior. The most important being the prevention of direct impact of the driver's head with the steering wheel and door pillar. Laminated windshields remain in one piece when impacted, preventing penetration of unbelted occupants' heads and maintaining a minimal but adequate transparency for control of the car immediately following a collision. It is also a bonded structural part of the safety cell. Tempered glass side and rear windows break into granules with minimally sharp edges, rather than splintering into jagged fragments as ordinary glass does. Crumple zones absorb and dissipate the force of a collision, displacing and diverting it away from the passenger compartment and reducing the negative acceleration impact force on the vehicle occupants. Vehicles will include a front, rear and maybe side crumple zones too. Safety cell. The passenger compartment is reinforced with high-strength materials, at places subject to high loads in a crash, in order to maintain a survival space for the vehicle occupants. Side impact protection beams, also called anti-intrusion bars. Collapsible universally jointed steering columns, along with steering wheel airbag. The steering system is mounted behind the front axle, behind and protected by the front crumple zone. This reduces the risk and severity of driver impact or even impalement on the column in a frontal crash. Pedestrian protection systems. Padding of the instrument panel and other interior parts, on the vehicle in areas likely to be struck by the occupants during a crash, and the careful placement of mounting brackets away from those areas. Cargo barriers are sometimes fitted to provide a physical barrier between passenger and cargo compartments in vehicles such as SUVs, station wagons and vans. These help prevent injuries caused by occupants being struck by unsecured cargo. They can also help prevent collapse of the roof in the event of a vehicle rollover. Post-crash survivability Post-crash survivability is the chance that drivers and passengers survive a crash after it occurs. Technology such as advanced automatic collision notification can automatically place calls to emergency services and send information about a vehicle collision. Pedestrian safety Automobiles are much more dangerous to pedestrians than they are to drivers and passengers. 2/3 of 1.3 million yearly auto-related deaths are pedestrians. 1. Since at least the early 1970s, attention has also been given to vehicle design regarding the safety of pedestrians in car-pedestrian collisions. Proposals in Europe would require cars sold there to have a minimum-maximum hood height. From 2006 the use of bull bars, a fashion on 4x4s and SUVs, became illegal in the European Union, after having been banned on all new cars in 2002. Conspicuity Lights and reflectors. Vehicles are equipped with a variety of lights and reflectors to mark their presence, position, width, length, and direction of travel as well as to convey the driver's intent and actions to other drivers. These include the vehicle's headlamps, front and rear position lamps, side marker lights and reflectors, turn signals, stop lamps, and reversing lamps. School buses and semi-trailer trucks in North America are required to bear retroflective strips outlining their side and rear perimeters for greater conspicuity at night. Daytime running lamps have been required in Nordic countries since the mid-1970s, in Canada since 1990, and throughout the European Union since February 7, 2011. Vehicle color. A 2004 essay on the relation between car color and safety stated that no previous studies had been scientifically conclusive. Since then, a Swedish study found that pink cars are involved in the fewest and black cars are involved in the most crashes. In Auckland, New Zealand, a study found that there was a significantly lower rate of serious injury in silver cars, with higher rates in brown, black, and green cars. The vehicle color study, conducted by Monash University Accident Research Center and published in 2007, analyzed 855,258 crashes that occurring between 1987 and 2004 in the Australian states of Victoria and Western Australia that resulted in injury or in a vehicle being towed away. The study analyzed risk by light condition. It found that in daylight black cars were 12% more likely than white to be involved in a collision, followed by grey cars at 11%, silver cars at 10%, and red and blue cars at 7%, with no other colours found to be significantly more or less risky than white. At dawn or dusk the risk ratio for black cars jumped to 47% more likely than white, and that for silver cars to 15%. In the hours of darkness only red and silver cars were found to be significantly more risky than white, by 10% and 8% respectively. Unused safety features many different inventions and ideas which may or may not have been practical about auto safety have been put forward but never made it to a production car. Such items include the driver's seat in the middle, rear-facing seats, and control stick steering. History 1700s are Euro 1800s automobile safety may have become an issue almost from the beginning of mechanized road vehicle development. The second steam-powered Fardia, created by Nicholas Joseph Cognot in 1771, is reported by some to have crashed into a wall during its demonstration run. However, according to Georges Adjan, the earliest mention of this occurrence dates from 1801 and it does not feature in contemporary accounts. One of the earliest recorded automobile fatalities was Mary Ward, on August 31, 1869 in Parsonstown, Ireland. 1920s In 1922, the Duesenberg Model A became the first car to have four-wheel hydraulic brakes. 1930s In 1930, safety glass became standard on all Ford cars. In the 1930s, plastic surgeon Claire L. Strath and physician C.J. Strickland advocated the use of seat belts and padded dashboards. Strickland founded the Automobile Safety League of America. In 1934, GM performed the first barrier crash test. In 1936, the Hudson Terraplane came with the first backup brake system. Should the hydraulic brakes fail, the brake pedal would activate a set of mechanical brakes for the back wheels. In 1937, Chrysler, Plymouth, DeSoto, and Dodge added such items as a flat, smooth dash with recessed controls, rounded door handles, a windshield wiper control made of rubber, and the back of the front seat heavily padded to provide protection for rear passengers. 1940s In 1942, Hugh de Haven published the classic mechanical analysis of survival in falls from heights of 50 to 150 feet. In 1947 the American Tucker was built with the world's first padded dashboard. It also came with middle headlight that turned with the steering wheel, a front steel bulkhead, and a front safety chamber. In 1949 Saab incorporated aircraft safety thinking into automobiles, making the Saab 92 the first production Saab car with a safety cage. Also in 1949, the Chrysler Crown Imperial was the first car to come with standard disc brakes. 1950s In 1955 a USAF surgeon who advised the U.S. Surgeon General wrote an article on how to make cars safer for those riding in it. Aside from the usual safety features, such as seat belts and padded dashboards, bumper shocks were introduced. In 1956, Ford tried unsuccessfully to interest Americans in purchasing safer cars with their Lifeguard safety package. In 1958, the United Nations established the World Forum for Harmonization of Vehicle Regulations, an international standards body advancing auto safety. Many of the most life-saving safety innovations, like seat belts and roll cage construction, were brought to market under its auspices. That same year, Volvo engineer Nils Bohlin invented and patented the three-point lap and shoulder seat belt, which became standard equipment on all Volvo cars in 1959. Over the next several decades, three-point safety belts were gradually mandated in all vehicles by regulators throughout the industrialized world. In 1958, Saab were first to introduce seat belts as standard. In 1959, American Motors Corporation offered the first optional headrests for the front seat. Also in 1959, the Cadillac Cyclone concept by Harley L had a radar-based crash avoidance system located in the on-the-nose cones of the vehicle that would make audible and visual signals to the driver if there were obstacles in the vehicle's path. 1960s effective on new passenger cars sold in the United States after January 1, 1964. Front outboard lap belts were required. Effective in 1966, U.S. market passenger cars were required to be equipped with padded instrument panels, front and rear outboard lap belts, and white reverse lamps. In 1966, the U.S. established the United States Department of Transportation with automobile safety one of its purposes. The National Transportation Safety Board was created as an independent organization on April 1, 1967, but was reliant on the DOT for administration and funding. However, in 1975 the organization was made completely independent by the Independent Safety Board Act. In 1967, equipment specifications by such major fleet purchasers as the City and County of Los Angeles, California encouraged the voluntary installation in most new cars sold in the U.S. of safety devices, systems, and design features including, elimination of protruding knobs and controls in passenger compartment, additional padding on the instrument panel and other interior surfaces, mounting points for front outboard shoulder belts, four-way hazard flashes, a uniform PRNDL gear sequence for automatic transmission gear selectors, dual-circuit brake hydraulic systems. In 1968, the precursor agency to the U.S. National Highway Traffic Safety Administration's first federal motor vehicle safety standards took effect. These required shoulder belts for left and right front seat vehicle occupants, side marker lights, collapsible steering columns, and other safety features. 1969 saw the addition of head restraints for front outboard passengers, addressing the problem of whiplashing rear-end collisions. These safety requirements did not apply to vehicles classified as commercial, such as light-duty pickup trucks. Thus manufacturers did not always include such hardware in these vehicles, even though many did passenger car duty. Volvo developed the first rear-facing child seat in 1964 and introduced its own booster seat in 1978. 1970s In 1974, GM offered driver and passenger airbags as optional equipment on large Cadillacs, Buicks, and Oldsmobiles. In 1979 NHTSA began crash testing popular cars and publishing the results, to inform consumers and encourage manufacturers to improve the safety of their vehicles. Initially, the US NCAP crash tests examined compliance with the occupant protection provisions of FMVSS 208. Over the subsequent years, this NHTSA program was gradually expanded in scope. In 1997, the European New Car Assessment Program was established to test new vehicles' safety performance and publish the results for vehicle shoppers' information. The NHTSA crash tests are presently operated and published as the U.S. branch of the International NCAP program. 1980s In 1984 New York State passed the first U.S. law requiring seatbelt use in passenger cars. Seatbelt laws have since been adopted by all 50 states, except for New Hampshire, and NHTSA estimates increased seat belt use as a result saved $10,000 per year in the USA. In 1986 the central third brake light was mandated in North America, with most of the world following with similar standards in automotive lighting. In 1989, companies in Israel implemented advanced brake warning systems, where the driver would be alerted as to how hard the driver in front of them was pressing on their brakes. This has yet to be implemented into mainstream America. 1990s In 1995 the Insurance Institute for Highway Safety began frontal offset crash tests. In 1997 Euro NCAP was founded. 2000s In 2003 the IIHS began conducting side impact crash tests. In 2004 NHTSA released new tests designed to test the rollover risk of new cars and SUVs. Only the Mazda RX-8 got a 5-star rating. In 2009, Citroën became the first manufacturer to feature Snow Motion, an intelligent anti-skid system developed in conjunction with Bosch, which gives drivers a level of control in extreme ice or snow conditions similar to a 4x4. In 2009, NHTSA upgraded its roof crush standard for vehicles weighing 6,000 pounds or less. The new standard increased the crush load requirement from 1.5 to 3 times the vehicle's curb weight. Safety trends. Despite technological advances, about 40,000 people die every year in the U.S. Although the fatality rates per vehicle registered and per vehicle distance traveled have steadily decreased since the advent of significant vehicle and driver regulation, the raw number of fatalities generally increases as a function of rising population and more vehicles on the road. However, sharp rises in the price of fuel and related driver behavioral changes are reducing 2007-8 highway fatalities in the U.S. to below the 1961 fatality count. Litigation has been central in the struggle to mandate safer cars. International comparison: in 1996, the U.S. had about 2 deaths per 10,000 motor vehicles, compared to 1.9 in Germany, 2.6 in France, and 1.5 in the UK. In 1998, there were 3,421 fatal crashes in the UK, the fewest since 1926. In 2010 this number was further reduced to 1,857 and was attributed to the 2009 Euro 2010 scrappage scheme. The sizable traffic safety lead enjoyed by the USA since the 1960s had narrowed significantly by 2002, with the U.S. improvement percentages lagging in 16th place behind those of Australia, Austria, Canada, Denmark, Finland, Germany, United Kingdom, Iceland, Japan, Luxembourg, the Netherlands, New Zealand, Norway, Sweden, and Switzerland in terms of deaths per thousand vehicles, while in terms of deaths per 100 million vehicle miles traveled, the USA had dropped from first place to 10th place. Government-collected data, such as that from the U.S. Fatality Analysis Reporting System, show other countries achieving safety performance improvements over time greater than those achieved in the U.S. Research on the trends in use of heavy vehicles indicate that a significant difference between the U.S. and other countries is the relatively high prevalence of pickup trucks and SUVs in the U.S. A 2003 study by the U.S. Transportation Research Board found that SUVs and pickup trucks are significantly less safe than passenger cars, that imported brand vehicles tend to be safer than American brand vehicles, and that the size and weight of a vehicle has a significantly smaller effect on safety than the quality of the vehicle's engineering. The level of large commercial truck traffic has substantially increased since the 1960s, while highway capacity has not kept pace with the increase in large commercial truck traffic on U.S. highways. However, other factors exert significant influence. Canada has lower roadway death and injury rates despite a vehicle mix comparable to that of the U.S. Nevertheless, the widespread use of truck-based vehicles as passenger carriers is correlated with roadway deaths and injuries not only directly by dint of vehicular safety performance per se, but also indirectly through the relatively low fuel costs that facilitate the use of such vehicles in North America. Motor vehicle fatalities decline as fuel prices increase. NHTSA has issued relatively few regulations since the mid-1980s. Most of the vehicle-based reduction in vehicle fatality rates in the U.S. during the last third of the 20th century were gained by the initial NHTSA safety standards issued from 1968 to 1984 and subsequent voluntary changes in vehicle design and construction by vehicle manufacturers. Issues for particular demographic groups. Pregnant women. When pregnant, women should continue to use seatbelts and airbags properly. A University of Michigan study found that unrestrained or improperly restrained pregnant women are 5.7 times more likely to have an adverse fetal outcome than properly restrained pregnant women. If seatbelts are not long enough, extensions are available from the car manufacturer or an aftermarket supplier then. Infants and children. Children present significant challenges in engineering and producing safe vehicles, because most children are significantly smaller and lighter than most adults. Safety devices and systems designed and optimized to protect adults are particularly calibration-sensitive devices like airbags and active seat belts can be ineffective or hazardous to children. In recognition of this, many medical professionals and jurisdictions recommend or require that children under a particular age, height, and/or weight ride in a child seat and/or in the back seat, as applicable. In Sweden, for instance, a child or an adult shorter than 140 centimeters is legally forbidden to ride in a place with an active airbag in front of it. As another example, in Austria, the driver of passenger vehicles is responsible for people shorter than 150 centimeters and below 14 years to be seated in an adequate child safety seat. Moreover, it is not allowed for children below the age of 3 to ride in a passenger vehicle without security system, whereas children between 3 and 14 years have to ride in the back seat. Child safety locks and driver-controlled power window lockout controls prevent children from opening doors and windows from inside the vehicle. Infants left in cars. Very young children can perish from heat or cold if left unattended in a parked car, whether deliberately or through absent-mindedness. In 2004, the U.S. NHTSA estimated 25 fatalities per year among children left in hot cars. Teenage drivers. In the UK, a full driving license can be had at age 17, and most areas in the United States will issue a full driver's license at the age of 16, and all within a range between 14 and 18. In addition to being relatively inexperienced, teen drivers are also cognitively immature, compared to other drivers. This combination leads to a relatively high crash rate among this demographic. In some areas, new drivers' vehicles must bear a warning sign to alert other drivers that the vehicle is being driven by an inexperienced and learning driver, giving them opportunity to be more cautious and to encourage other drivers to give novices more leeway. In the U.S., New Jersey has Killy's law citing that teen drivers must have a decal on their vehicle. Some countries, such as Australia, the United States, Canada, Talatone, and New Zealand, have graduated levels of driver's license, with special rules. By 2010, all U.S. states required a graduated driver's license for drivers under age 18. In Italy, the maximum speed and power of vehicles driven by new drivers is restricted. In Romania, the maximum speed of vehicles driven by new drivers is 20 km per hour, lower than the national standard. Many U.S. states allow 18-year-olds to skip some requirements that younger drivers would face, which statistics show may be causing higher crash rates among new drivers. New Jersey has the same requirements for new drivers up to the age of 21, which may obviate this problem. Elderly. Insurance statistics in the United States indicate a 30% increase in the number of elderly killed, comparing 1975 to 2000. Several states require additional testing for elderly drivers. On a per-driver basis, the number of fatal and overall crashes decreases with age, with some exceptions for drivers over 75. The overall trend may be due to greater experience and avoiding driving in adverse conditions. However, on a per-miles traveled basis, drivers younger than 25 to 30 and older than 65 to 70 have significantly higher crash rates. Survivability of crashes decreases monotonically with the age of the victim. A common problem for the elderly is the question of when a medical condition or biological aging presents a serious enough problem that one should stop driving. In some cases, this means giving up some personal independence, but in urban areas often means relying more on public transportation. Many transit systems offer discounted fares to seniors, and some local governments run senior shuttles specifically targeted at this demographic. See also. References. Further reading, http, www.worldbank.org. Road Safety HTM, Furness, Sue, J. Connor, E. Robinson, A. Norton, S. Amaratunga, A. Jackson. Car Color and Risk of Car Crash Injury, Population-Based Case Control Study. British Medical Journal 327 1455 1456. BMJ Publishing Group. Archived from the original on December 11, 2005. Retrieved January 1, 2006. IEEE Communications Magazine, April 2005, Ad hoc Peer-to-Peer Network Architecture for Vehicle Safety Communications, IEEE Communications Magazine, April 2005, The Application-Based Clustering Concept and Requirements for Inter-Vehicle Networks, Safe Vehicle Colors. Land Transport NZ. 2005. Archived from the original on February 2, 2006. Retrieved January 1, 2006. Pednem, McGee K., Sharma G. The Injury Chart Book, a graphical overview of the global burden of injuries. Geneva, World Health Organization. Archived from the original on November 24, 2005. Retrieved January 1, 2006. ISBN 978-92-4-156220-1, Physics Today, January 2006, Vehicle Design and the Physics of Traffic Safety, Evans, Leonard. Traffic Safety. Science Serving Society. ISBN 978-0-9754871-0-5. External links, European Safety Ratings, National Transportation Safety Board. Child Passenger Safety Resource, National Agency for Automotive Safety and Victims' Aid, Japan, No More Flying Glass When Vehicles Collide. Popular Science Monthly, February 1919, bottom page 27, scanned by Google Books, Efficacy, National International Practices and Motivational Factors of Lifelong Driver Education for the Aging Population.